Dear student, a new episode number 76 for class 10 physics. The chapter is magnetic effect of electric currents, and in that, in previous class, I have taught you about the Fleming right-hand rule and Fleming left-hand rule. According to Fleming left-hand rule, we know the direction of the force acting on a current-carrying conductor in a magnetic field, and with the help of Fleming right-hand rule, we know the direction of the current, induced current in a coil due to magnetic field. And these two laws are applied for two different devices in DC, in motor and generator. I have also taught you that what is motor? Motor is a simple device in which the input is electrical energy and the output is mechanical energy. And DC generator is a simple device in which input is mechanical energy and output is electrical energy. And this type, the generator produces electric current. That may be AC current or DC current. It means current are of two types, DC and AC. What does it mean by DC? DC is the current which flows in a same direction at every moment through whole circuit. In circuit, it flows in same direction. A direction is not changed. And it is created from cell or battery. The cell is represented by two parallel lines, and the battery is a combination of a number of cells. Here I have joined the three cells. The big line, positive terminal, the small line is negative. This is the source of DC, and DC current is also produced by generators. And AC current, full forming alternative current. It means this current changes its direction of flow in a particular interval of time. In every particular interval of time, it changes its direction. And in India, it changed its direction 50 times. So its frequency is called 50 Hertz. For DC current, if you draw a graph between I and T, then it is a straight line parallel to time axis. This is for DC. And if you draw a diagram for AC current, then it is not parallel to time axis, because the AC current from zero it goes at highest, and then it is the current I it indicates, and it is time. This part is plus and this part is minus of current. Goes high, comes to low, here it is zero, and again it goes maximum low and reaches to zero. In this way, it forms one wave and such 50 waves are created. It means it changes 100 times direction, and also it is 100 times becomes zero. The current is reaches to zero, then start and goes to highest, and again it comes to zero, then it goes to lowest, and then again it comes to zero. In this way, it completes one wave, and such 50 waves are formed during propagation of the AC current. In America, the frequency is 50 hertz, and America, the frequency is in USA, the frequency is 60 hertz, and the potential difference is 110 volt. In India, the potential difference is 220 volt. They are more modern in respect of speed, their frequency is greater. And so all electrical devices which run in America does not run in India, which is made properly for America. The TV does not run at this situation on Indian supply, current supply. Yes, my student, it means, you know, the current is of two types. DC current, it does not change its direction at any moment, and AC change its direction in a particular interval of time, and it changes 100 times direction, and it forms 50 hertz waves. It forms 50 waves, and the graph between the current and the time is like this for AC, and for DC, the graph between I and T is like this. This is parallel to time axis, and in this, crystal terms are made. It means the generator and motors are of two types: DC motor and DC generator, and a device through which AC current produced or in which AC current is given, that is AC motor or AC generator. Here, today, we are going to discuss about the DC generator, how it works, what are the construction of the DC motor, on which principle it acts, and in DC generator, framing, left or right hand rule applied. All things we learned just now. Remember, recall the framing left hand rule. I have taught you that if you stretch the three fingers of left hand, thumb, forefinger, and middle finger in such a way that they are perpendicular to each other, and if the fourth finger indicates the magnetic pole, in this here, north is starting here, magnetic field is going in south direction, from this toward this north. This indicates the north pole, and the magnetic field is going towards the south pole, and the middle finger shows the direction of the current. If both are known, then the thumb indicates. It means this is applied for which device? In which we have to find the direction of the force in which the device rotates, and this is done in DC motor. And for DC generator, you apply the right hand thumb rule, in which this fourth finger indicates the magnetic field. The thumb indicates in which the force is acting, and the middle finger shows the direction of the current produced. This is for DC generator. Here we are going to discuss about the generator. What is generator? Generator is a simple device which converts the mechanical energy into electrical energy. And this act on the principle. The principle of working of AC generator is based on the electromagnetic induction. What is electromagnetic? That current is called induced current, and this phenomena is called electromagnetic induction. On this principle, the generator works. Right? The principle is known. Now, I am going to draw the diagram for a DC generator, and then we will discuss about the main component, main parts of the DC generator. That are, just I am writing first, main component of DC generator. The first, magnetic field. Second, armature. Third, slip rings, and fourth, source of energy. Snake, brushes, and sliding contact. Brushes or sliding contact. Contact. These are the main components of the DC generator. At first, what is magnetic field? In generator, a permanent magnet is present to produce magnetic field lines. It is north pole and this is south pole of the magnet. And the magnetic field is parallel to each other between the north pole and south pole. It is inside the generator present, the magnetic present for produce magnetic field. Second, the armature. Armature is a coil having a large number of turns of insulated copper wire. Generally, today aluminum wire is also used, but actually an insulated copper wire wounded over iron cores is called armature. Means the coils of insulated copper wire present in the shape of a bunch of coils wounded over a iron core. And the third is slip rings. If you take a ring of iron like this, and if you cut it here, you make two pieces of this slip ring, then this is called, with this, a carbon brush is connected with this slip. It is made up of graphite. Why it is used? Why not a metal is used? It is a contact brush between, it creates a contact between the slip and the circuit. The circuit and this slip. The question is why graphite is used? Due to the friction between the sliding contact and the slip rings, a high temperature is increased And due to that, oxidation occurs in the metal, and thereafter the layer is coated with oxide and contact is discontinued and current is stopped to flow. So, and graphite is a non-metal and it does not do reaction with the oxygen at normal temperature where the metal acts, and it is also a good conductor, very good conductor of electricity. So graphite is used. So these are the main components of the generator. I am going to draw a diagram, very easy diagram, to understand the construction of generator. One thing is remarkable. The generator and motor is same device. There is no any change at all between the DC motor and DC generator. Same device is work both. If you supply energy in that device, it behaves like a DC motor, and if you give mechanical energy to that device, then it behaves like a generator. It means if you supply mechanical energy, then it produces electrical energy, and if you supply electrical energy to the device, then it behaves like, gives mechanical energy, and it behaves like a DC motor. So, one single device do two types of work. One time it is generator and one time it is motor. Here, these are the main component of the DC motor or DC generator. In both, the components are same. Then this is North Pole, this is South Pole. And it is fixed on an iron shaft. It is an iron shaft on which the armature is fixed. And the coil are coming. This is half sleeve, and this is connected. It is a carbon brush, and also a second half sleeve is here, and the wire is connected with a half sleeve with the carbon brush, sliding brush. With making in mind that the sleeves are moving with the axis of the armature. It means, according to the armature, the sleeves also rotate. If armature is rotating clockwise, then the sleeve rings are also rotating clockwise, and if armature is moving anti-clockwise, then sleeves also rotate anti-clockwise. But these two carbon rods, C1 and C2, does not rotate, they are stationary. They are stationary. And now, this is the here. and the carbon brush is connected with a load. Load is indicated like this. It may be bulb, it may be free, it may be anything, AC, anything, here is load. And this is carbon brush C1 and C2, and this sleeve is R1, R2, and a half sleeve is R1. Okay? The two is, and the R1 and R2 half sleeve is connected in contact with C1 and C2 carbon brush. Suppose the AB one arm of this armature and CD is the second arm of this armature. Okay? And a magnetic field is perpendicular on the current carrying conductor. What is the direction of the force is needed in this, and the left hand rule gives the information about the force acting on the current carrying conductor. So in DC generator, we apply the Fleming left hand rule. Or suppose it is in vertical position, if you take it horizontally like this, then what happens? This is in front of you, and this AB side is in left of your left hand, and the CD side is in right hand. Okay? And you are rotating this generator by a machine. You are giving mechanical energy to this generator. Okay? And this generator start to move clockwise. Suppose the generator, the mechanical energy is given, and this armature is starting to move clockwise. Means, suppose this is armature, and this side is AB, and this side is CD. Suppose, and a machine is starting to move it in clockwise, like this. So AB goes in upward direction. Then what is the direction of the force? What is the direction of the force? This is generator. Right hand, yes, you have to apply it. In right hand, the current direction is found, and in left hand, the force direction is known. The current DC generator is produced, the right hand is applied, not DC, left hand, yes. Current, you are rotating it like this. This is armature, and this is right hand. Okay? The magnetic field is this. Okay? Now you are moving this side in upward direction. The current comes out like this. See, the armature is this, and this is AB side, this side, and this is CD side, and this is right hand. Magnetic field like this, and you are rotating this side in upward direction. Then the current will start to come in this direction. Yes? And it is going in downwards, the current will start to move in this just opposite direction according to the right hand thumb rule. See, thumb is showing the direction in upward direction, means current is going in this direction. And in opposite, it flowing. Here, it is null point. 1 minute excuse. Hello. Yes, my students, excuse for disturbance. This is generator. We have to find the direction of the current because we are giving the mechanical energy and it produces electrical energy, and this is found with the help of Fleming right hand thumb rule. This is the direction of the current, this is the direction of the magnetic field, and this is the direction of the motion of the armature. We are discussing with the help of this tester. The diagram is in vertical position. If you uplift it in this direction, it means like this. This is like this. And now here, this position. And this is armature. Suppose right hand, the rule is in front of you, the magnetic field is in this direction. And this side is going in upward direction. The AB side is going in upward. Current will go in this direction. Yes, in this direction. In this direction. Just opposite, in this side, the current goes in this direction. According to the left hand rule. Okay, students. This brush is in contact with this sleeve. So that in this circuit, the current starts to move in this direction, comes here and come to back here, and the circuit is completed. Now, now think, this is at this position. Means it rotates and comes here. It means both sides are at null point. It is not going in upward direction or downward, and the bottom side means CD side is also in the middle position. It is not going in upward or downward. The energy is zero. Now, see, it goes in upward direction. Which side? The CD side is going in upward direction. Means the CD side is going to take the position of AB. So the direction of the current in CD is similar to the AB, means CD reaches here, and now the CD is here, and AB side is here after rotation. AB is here, but the flow of current is similar, but the direction of flow of current in both sides is similar. So in the circuit, the current flow in same direction. Why? The sleeve R2 is now in contact with C1 carbon brush, and the sleeve R1 is in contact with the C2 carbon brush, and so the direction of the flow of current is in the same direction. In this way, this DC generator works and produces electrical energy, and the direction of the electrical energy is found with the help of the Fleming right hand thumb rule. Here, DC generator, you are giving mechanical energy and getting the energy, and if you give it current, means here you are connecting a cell, a battery. You have connected here a battery, means a combination of cells are connected here. Then you are supplying electrical energy to this device. Then it works like a DC motor. Then it works like a DC motor, and it works with the help of the Fleming left hand rule. And every working is similar to the generator. So my student, I have tried my best to teach you on this white board in front of me. Classes are open, then I will exhibit you a model to understand this DC motor and generator. I think that will help you very well. and it is very vital for the board examination. Some question must come related to the DC motor and DC generator. If you are getting in trouble, I think you must think that how it is rotating the working of the DC motor or generator. It may be not clear, may be clear, I think, because from 15 years, I think that many students ask that again and again repeats the working of the DC motor and generator, and I have to repeat that. Please try your best with your book. I think that you are a talented student, you are intelligent, you may follow this. Otherwise, WhatsApp is open. Please ask questions related to this. I want to try my best by voice or by writing. Thank you, my students. Have a nice day. Make a nice day. God bless you.